Welcome back. In this video, we'll perform exploratory data analysis, or EDA, on our annotated waste dataset. This step is essential to understand our data before training any object detection model like YOLO. I've already added the dataset to Kaggle for easy access and reproducibility. Let's start by inspecting the dataset structure. We're working with 7 specific waste categories: biological, cardboard, glass, metal, paper, plastic, and trash. Each image in the Images folder has a corresponding annotation in the Labels folder, formatted in YOLO format. Let's visualize a few annotated images to make sure the labels are accurate and the classes are well distributed. Let's start by examining the dataset structure. If you're using Kaggle, make sure you've added the annotated waste dataset to your notebook. We have 2 folders, one for images and one for YOLO format annotation files. Each .txt file contains one or more lines, each representing a bounding box. This script is a quick way to count your image and label files. It sets the dataset path, then finds and tallies all JPG images and TXT labels. Just run it to instantly see how many files you have for each. Here's what a label file looks like. The format is class ID, X center, Y center, width, and height, all normalized between 0 and 1. Next, let's count how many annotations we have per class. This code counts how many annotated objects belong to each waste class by reading through all the YOLO label files. It maps the class IDs to their names, tallies the occurrences, and then uses a bar chart to visualize the number of bounding boxes per class. From the results, Cardboard has the most annotations, while the other classes have fewer. This gives us a clear view of class distribution and highlights any imbalance before training. Let's visualize a sample image with its bounding boxes. Here, we write a function to visualize YOLO annotations on a sample image. The function reads the image and its corresponding label file, decodes the YOLO format bounding boxes, and converts them into pixel coordinates. It then draws each bounding box on the image using OpenCV, labeling them with their class names. Finally, we display the annotated image using Matplotlib to verify that the bounding boxes and class labels are correctly aligned with the objects in the image. This gives us a quick visual check to see how well the annotations are placed. It's especially useful for catching errors before training. Let's check if there are any missing images or labels. Our dataset is perfectly aligned with no images missing labels and no labels missing images, indicating it's ready for training.